So far we learned about ideal transformer. Now we're going to learn about practical transformer. Okay, practical transformer is nothing but a transformer with losses. Okay, I'm going to recap what is N1. N1 is number of primary turns, N2 is number of secondary turns, V1 is the primary source voltage, V2 is secondary load voltage, I1 is a current passing through the winding 1, I2 is current passing through winding 2. E1 is induced EMF, whatever the EMF induced in this coil, I'm representing that as E1. Induced EMF in secondary coil is E2. So we know that we have two types of transformer, one is step up, another one is step down. Now it doesn't matter, every transformer, every machine, okay, will have some losses, okay, power losses. So when it comes to the transformer, what are those power losses? Power losses of a transformer, one is called iron losses, also called core losses. Iron losses or core losses, both of them are same. These losses are constant. Doesn't matter what type of load you apply, as long as it's turned on, automatically these losses are going on in the machine, in the transformer. One is called iron losses are two types again: hysteresis losses and decurrent losses. Hysteresis losses we can minimize by choosing a good magnetic material. Eddy current losses we can minimize by slicing it up and putting an insulation between them, so that way the core resistance will increase, the induced currents are going to go down and losses are going to go down. And the second one is copper losses. These copper losses are variable losses. Variable in the sense it depends upon the load. If it is more load applied, more copper losses; less load applied, less copper losses. So we have primary copper losses and secondary copper losses. Wherever we use copper wire, there we have copper losses. Okay, we indicate with that's a copper loss. Now if we consider all those losses, the equivalent circuit is going to be look like this. Okay, so here the R1 represents the primary coil resistance of this primary coil. Okay, R1 is resistance of the primary winding, and X1 is the reactance of the primary winding. So the coil is nothing but, the wire is wound like a coil. Every coil will have reactance. That reactance is X1. Now R2 is resistance of the secondary winding, X2 is reactance of the secondary winding. RC, resistance of the core, this represents the iron losses. So here he mentioned ZC, but basically that's RC, and this is XM. XM is the leakage reactance. I mentioned is XC, but it is XM. XM represents the leakage reactance of the core. Usually compared to the R1, X1, R2, X2, this RC and XM are very big values. Okay, so whatever current coming here, I1, okay, out of I1, I0 is going to go through the core because of the losses. Now I1 prime or I2 prime is going to the core. Whenever you see these two lines between the two coils, that's ideal transformer. As I mentioned, we are talking about practical transformer, right? So the resistance reactance I already pulled out. It's right here, representing right there. So that's the reason I'm representing this as an ideal transformer. Okay, this is secondary coil resistance reactance, secondary coil resistance. Okay, and that is V2. So this is a practical transformer. Now when we are solving examples, how do we solve for quantities, required quantities? Now, so the transformer is magnetically coupled circuit, right? There is no electrical connection. Then how the primary winding is going to see the load resistance? Okay, that's what I'm going to define in this case. I'm taking this as an ideal transformer. N1 is to N2 is a transformer ratio or turns ratio. So N2 over N1 is nothing but transformer ratio. I'm calling that as N. Now the Z, instead of L, I'm going to call this as Z input. what is the input resistance. So here I have V1, I1 and I2, V2. I can clearly see ZL is nothing but V2 over I2. Now Z input, can I write this as V1 over I1? Okay, and we know that V2 over V1 is nothing but N. Okay, so what I'm going to do, I'm going to substitute V1 equal to V2 over N. At the same time, I1, I can write this as I1 over I2. So I1 equal to N times I2. So can I write this as V2 over I2 times 1 over N square? I already have V2 over I2 equal to ZL. So ZL over N square. So what I can do, I can transfer this load impedance to the primary side. When I transfer to that load impedance to the primary side, we call this as ZL prime. Okay, this represent equivalent. So ZL prime is equivalent load impedance after transferring it to the primary side. Okay, so the ZL prime is nothing but ZL over N square. So we can transfer load impedance from the primary side to the secondary side, or to the secondary side to the primary side. So in this case, I showed you how to transfer impedance from the secondary side to the primary side. So from the ideal case, so from the ideal transformer, what I'm going to do, I'm going to transfer those ideal the secondary impedances to the primary side to make an electrical connection. Okay, so here it is. Okay, so this is ZL prime, which is ZL over N square. So this is X2 prime, equivalent of that's a reactance, secondary reactance on the primary side. So equivalent reactance of the secondary on the primary side, X2 prime, which is X2 over N square, and N is nothing but N2 over N1. Here also R2 over N square. Okay, this is R1 and X1. This is R0 and XM. Now this R0 and XM are very small. These numbers are very big. What I'm saying, the current passing through this is very small. So the current here, I'm calling this as I2 prime, and the current here is I1. Okay, I1 is approximately equal to I2 prime. So what I'm going to do, I'm going to move this from here to here. It's not going to make any difference. So when I move it, it's going to be R0 right there and XM. Now I have R1, X1, R2 over N square, X2 over N square, which is X2 prime, R2 prime, and ZL prime. Okay. Now these two resistors are in series, these two reactances are in series. So I can combine those two. Okay, when I combine those two, I'm going to call this as R01. This is total resistance on the primary side. Total resistance of the transformer placed on the primary side. Okay, and X01 is total reactance of the transformer placed on the primary side. Okay, and you will have ZL prime. Okay, so here I'm going to represent this as Z01. That's the total impedance of the transformer after transferring everything into the primary side. Now this is a simple electrical circuit. I can solve for required parameters. Same way, how we transfer the impedance from the secondary to the primary side, instead of transferring them into the primary side, we can transfer primary side quantities into the secondary side. So if we transfer primary side quantities into the secondary side, so here we have R2, X2, we are not messing with them, and ZL. Okay, now what I'm going to do, I'm going to transfer this R0 prime XM prime. Whenever you see prime, that indicates that impedance is transferred from one side to the another side. Okay, so here is R1 prime and XM prime. Now when we transfer primary to secondary side, you're going to multiply n square. So this is R1 times n square. So when you transfer something from the secondary side to the primary, we are going to divide with n square. When we transfer primary to the secondary, multiply with n square. Okay, n square times this is x1. Okay, here also n square times R0 and n square times xn. Now same thing, the current here, this is I2 current is coming over here,